Hello everyone, we are live again with another bootcamp session. Today we are going to cover uh, event bridges. I just forgot that for a moment. So today we are going to cover the event bridges and we'll see how it will be helpful for us. Sazia, do you want to add something?
Yes, when you talk about serverless, basically everybody will tell you basically serverless you basically do event-based programming. Now imagine events are basically you broadcast them. Imagine if every event are not going through a central processing point, who will be able to track them? Who will know what is happening in a system? So therefore, EventBridge in the last year, AWS basically came up with this EventBridge for basically serverless event-driven applications. And what we'll do is, Homa will start off by introducing EventBridge, and then Varis will go in depth, and then Zeeshan will do the code, show you the coding. This one is a very important topic because the main architecture of serverless computing is done through EventBridge. Homa, please take over.
Okay, sir. I would like to share my screen.
Sure.
Is my screen visible?
Yes.
Are you people able to see my screen, sir?
Yes.
Okay.
Yes, we
So
can.
a brief intro of few terminologies related around serverless and monolithic and microservices. So there is terminology used tightly coupled and loosely coupled. Tightly coupled apps have functionalities, components which are actually integrated so well, so interdependent that changing one would be very difficult to change other. If one fails, everything fails. It reduces flexibility, and the image itself is clear. Then we came along with loosely coupled applications, which are actually less dependent on each other. They actually communicate with each other through either APIs, sharing the data. This is more relevant in cloud environment, cloud ecosystem, because each service is an individual entity. We actually invoke them, we connect them, we share the data among them. And this is called event-driven architecture. And in AWS, event-driven architecture is carried out by EventBridge. Two main thing in EventBridge architecture is like there will be a service which would be some sort of event producer, and then on the other hand you will be having some services which will be like event consumer. So event emitter would somehow trigger something and as a result process some information and then pass forward to the consumer along with some data. This was done earlier through APIs too. I'm not talking about yeah. But as your application grows, this infrastructure looks like this. So this calls for solution, and that solution was event buses. So instead of each and every services handling events on their own, they actually connect themselves to just one event bus. There can be multiple event buses, and then event bus actually process this, that which event should be forwarded to which services. Event buses also comprises of some set of rules. So this set of rule actually states that event emitted by service A should be forwarded to service 1, 2, 4, and 5. Event rules also contain some metadata. So that metadata would have some additional information, the data which would be required by the desired producer consumer. And event bridges in AWS can have sources from AWS services, SaaS partners, which are actually affiliated with AWS, and they are like software as a services, but you can integrate them as sources, and your custom app can also be event sources. Event targets could be any not any, maybe there are more than 90 services which are actually event targets. And then event buses can be of three types. Event buses can be of custom event, which is provided by default by every service event. And then there can be your custom app. And lastly and finally, SaaS events can have types of event buses too. That's for my presentation.
So your mic is on.
I'm saying thank you so much. You have done a marvelous job. And
we cannot hear you, sir.
Sorry.
You can hear me now? You can hear me now?
Yes, I can.
Okay.
I guess everybody can.
What I was saying is basically, Huma, you have done a marvelous job. Let's move over to Waris, and he will basically take it from there. Thank you so much. I think Waris is not able to hear me.
Waris, can you hear me?
Yeah, I can hear you now. Can you guys hear me?
I can hear you.
Yeah, I can hear you. Your video is kind of stuck. I think I should reconnect. Let me reconnect.
I guess he is reconnecting in a moment.
Zeeshan, would you like to add something about EventBridge in the meanwhile?
Yeah, basically, the point Huma covered is basically the problem when we are working in an application, or we have multiple application which needs to communicate with each other. So sometimes what we do is we tightly integrate them together in such a way that these services cannot live without each other. So if you down one service, other service will have to be down, or if there is a problem in one service, other service will, because everything is quite coupled in a way that you, for each action you need to have an access or a running application of second application. So what EventBridge and Event Buses does is the pattern, the architecture, or the pattern of event driven architecture is basically that when you communicate with application, you do not tightly couple your application with another application. This can be anything. Maybe this can be the case of two independent application you are talking to a third party services, or this can be your two applications, but to make them in a way that they are independent. The benefit is when you send something, or you make a request, or you add, or you send something to or send an event to other application, what happen is you just send an event. You do not directly call other applications some resource or some API or directly. So you just register an event, and the other application which is listening to a particular event will take that event and do whatever execution that other application needs to done. The benefit is that you will not be tightly coupled with other application. Other application will also not be tightly coupled. So any other application can generate same particular event. Will be uh, let's say I have application one which is generating an event to introduce something, and an application two which is consuming that particular event. So the benefit is if you remove application one and create an application 4, 5, or 6, and if that application will generate a same particular event, so your consuming application will have no effect because it's just consuming the events. So it will be not a problem for your application. That's the one part of it. Varis, you can hear me now?
Yeah, I can hear you guys. Can you hear me?
Yes.
Okay,
Yes,
now
we
go
can.
ahead. Please go ahead.
Okay, sure. Sure. So, can you guys see my screen? Okay, so what I wanna concentrate on is that what are event-driven systems and why do we actually need them? Okay, so what is the difference between event-driven systems and non-event-driven systems? Okay, so for now, just take my word that mostly event-driven systems are asynchronous systems. Okay, and non-event-driven systems are mostly asynchronous systems. Okay, so synchronous versus asynchronous. Event-driven systems are asynchronous, and non-event-driven are synchronous. Okay. So before explaining the non-event-driven systems, I'm just going to give you a brief. I'm just going to show you some few examples of non-event-driven examples, so that you can understand that what are the problems in them and why do we actually need to use event-driven systems. Okay. So just make it bigger. So this is like just a very basic synchronous model, a very basic non-event-driven system. So it's like an e-commerce website. So the client places an order, it runs a service. That's an order service that completes the order. Then it's in turn invokes another service that creates an invoice, which sends message back to the order service, and then order service updates the client. Okay, so this is a very small example, and it only has two services in it. So it doesn't really it doesn't really matter in such a small application whether your architecture is event driven or it's not event driven. Okay, it's okay to implement non-event driven architectures in such a small and simple application. But if you see this example, this is where things get interesting, because in the previous example, there was only one service connected to the order service. Okay. Now I have actually connected the services with the order service. Now again, the client places order. This service runs, and once it's completed, it executes three other services. Okay. So now this means that in the code of this service, we have some APIs. We have an API that executes each one of these services. Okay, we have an API for this service that executes this service, and then we have a separate API for this service and a separate API for this service. Now let's say that I want to add a few more services like this. I want to add not 3 but 6 services. Now to do this, I would actually have to change the code in this service. Okay, I would actually have to invoke some more APIs, and not only invoke APIs, I might also have to implement the retry mechanisms, the fallback mechanisms, the errors. Okay, so this means that these services are coupled to a part of code in this service. Okay, and this is a problem, right? Why? Because let's say that my team is working on this service. Now my team would be dependent on the team that is working on this service. Why? Because a part of my because my service is actually coupled to some part of this code, right? So and another example would be that if that API changes, like if that API gets updated, the code in this service would have to be changed, and the code in this service might also have to be changed. Okay, so the inputs and outputs of these services are dependent on each other. Therefore, they are called tightly coupled services. Okay, and they can actually get very difficult to manage, especially if it's a big application. This is a very small one. Imagine if this service was tightly coupled with like 20 services, it would be really difficult for the team who's working on this service to manage it. Okay, and also it's really difficult to find a bug and debug it in such architectures. Okay, now let's have a look at another example. So again, it's an e-commerce application. Order service invokes 3 services, and then the payment service that completes the payment invokes a fulfillment service that fulfills the order, and then that in turn triggers another service, shipping service, that might actually be getting the tracking order from the shipping company. So far so good, but what would happen if an error occurs in this service? What would happen if an error occurs over here? This means your order has been cancelled, it has not been fulfilled. So what you would have to do is this service would actually have to send a message to this service that cancel that invoice. We will have to reverse the payment. We will have to refund the customer. We will have to send another message. Then we will also have to do some changes in this service because our order has been cancelled. And it's possible that the failure occurred after this shipping service was triggered. So although our order has been cancelled, this is still going on. So you will also have to cancel this. Some other service would have to send message over here. So you can see it's a chaos over here. Even though it's a very small application, it's a chaos. It's really difficult to manage such architectures in a non-event driven architecture. Okay. And imagine if there was a service that is not even communicating with this service, but it needs to be cancelled now. It would not be possible. It would be really difficult, right? And another problem with these architectures, non-event driven architectures, is that if one service fails, the other services tend to fail as well, and your entire system can go down. Why? Because they're very tightly coupled. They're dependent on each other. Their inputs and outputs are dependent on each other. Okay. Now, therefore, now the solution is that we have event-driven architectures. Now, this is an event-driven architecture. Now, it's the same example, this part of the code, but now you can see there are some changes in it. This service is not directly communicating with the other services, but you can see that there's one extra thing over here that is called event bus. So this event bus is the critical part of any event-driven system. So event bus is nothing but it just receives events from different services, it stores events, it filters events, and it sends events to different services. Okay. So in this case, it is receiving event from this service and sending events to these services. Okay. Now the thing is that this service is not directly communicating with these services. Okay. It is only sending an event on its completion to the event bus. Okay. So this service completes, it sends an event, and these services are polling for events from the event bus. Okay. And so right now I've only shown one service that is sending the event to the bus. There could be hundreds of services, but these services are saying we are only interested in the events that are coming from this service. Okay. So we have applied a filter before receiving the events. Okay. So as soon as this event bus receives an event from this service, it will be received by each one of these services, and as soon as the event is received by these services, they will start executing. So you can see that the process is same. After the completion of this service, these services are executing, but this service doesn't even know that these services exist, right? Why? Because there's no code in this service that is coupled to these services. This service is only concerned about sending the events, and these services are only concerned about receiving the events. They don't know that this service exists, and this service doesn't know that this service exists, right? So this is what we call event-driven architecture. Okay. And now let's say that I want to add another service over here. So in the previous example, if I had to add another service over here, I would actually have to contact the team of the service. I would actually have to tell them that, okay, I'm adding a new service. Please, can you integrate that code in your service, and I'm going to integrate your code in my service. But in here, what I will have to do is I will only have to make a new service, and I will only have to subscribe to the event that this service is generating. I would not even have to talk to the team of this service. I don't even care what's written, what's the code in this service. I'm only concerned about the event that it is already generating. I'm only going to receive that event, and my service should work fine. So you can see all these services are independent now. It's very easy to manage them, and it's very easy to debug them. Like you can actually pinpoint the bug or the problem in the system. Okay. Now, if I go back to this example, now let's try implementing this with an event-driven architecture. Now, if we had an event bus, all we had to do was that send an event from this service that the order has been cancelled, and all the other services can just poll that event from the event bus and revert their changes and do whatever they want to do, like they perform the required actions. So in that case, you won't have to send individual messages to each service. So event-driven systems makes event-driven architecture makes such a system very easy to manage. Okay. So all these services can just pull that error message from the event bus. Okay. And so the service that allows us to do that is Amazon EventBridge, and it's like serverless, pay as you go, just like Lambda functions. So it supports 90 plus AWS services as sources. So sources mean the services that can actually put events on the event bus, and targets mean that services that can read events from the event bus. So right now, only 17 services can be used as targets, and it's also quite cheap. You can see it's $1 per million events. Okay, and these are just so this is just showing that what EventBridge offers us. So it decouples your system, your architecture. You can easily send events, receive and send events, and filter them. Improve availability. This means that if one service fails, the others doesn't fail. They keep running because they're not dependent on each other. Okay, and you can easily also it is also very easy to integrate third-party services, like you would only be concerned about receiving their events and sending them events. Okay, that's it. So I think that's pretty much it. Coding would be done by Zeeshan. So over to you, Zeeshan.
Okay, so Waris and Huma has literally covered in quite much of detail what event services. So I'll be directly move towards the how we'll see event bridge and event buses in our console, AWS console, and how we are going to implement in the code. So let me share my screen. Okay. So first of all, it's again quite easy. You can from AWS console you can find out even bridge service. It's in a full-fledged service of AWS. Again, AWS done a marvelous job in implementing this particular service. On this interface, when you come over here, this interface directly asks you to create a rule. So in general, whenever you create your AWS account, they create one default event bus. The bus, what Waris and Huma has explained, that this bus is actually working. So all the event are registered to that bus, or this, or whenever the particular application is pulling of event, so that particular service is talking to that bus and fetching the data. If you generally you will keep that default bus, you can create a custom bus, or whenever you want to communicate with different accounts or something. Otherwise, the default service bus is already available to you and you do not have to do anything else. So the bus will be available. First, I'll show you how we are using and creating a rules from the console, so you understand what this actually is, how it actually works, and then we will from the code it will be breeze if you understand from there. So the bus, we already have bus for the rule. What rule is basically that you create a rule that if any particular event occurs or any particular consumer wants to learn, so it needs to understand that particular rule. If it matches the rule, then that particular service will be gets called, or the event will be sent to that particular service. So what we have to do is, let's say this buses already exist. In the rule, we'll go and create a rule. Let's say I'll give it a name, demo second rule. Description can be anything, it's just a description. At this moment, we are creating a event pattern, but you can use the scheduled events. So that means event can
Zeeshan,
fire
could you
based
please
on
increase the focus, please?
Sure.
Thank you.
So first of all, we'll create the rule, give it a name, and then a description, and then we'll select the event pattern, not the event schedule. We'll select the event pattern. So what event pattern will do is will identify that if particular event has that source, if particular event has that particular value, or it is coming from that particular or type, then it should be fired or it should be consumed. So I'll show you how we can define that pattern. Schedule is, you will identify that after how many minutes, hours, or days you want to fire that particular event. So for our case, I'll select event pattern, and then from that we'll pick the predefined pattern service. Predefined pattern service means we'll select AWS. Instead of all event, we'll select AWS, and now you can select a particular service of AWS, either it's Lambda or AppSync or anything. So to easily explain, what we can do is we'll pick the Lambda service, and what we want is all type of Lambda. So any type of event that fires by a Lambda function, that should be listened by a particular service. So someone will be listening. If that particular rule, if someone is listening to that particular rule, that service will get the event. So here you can see, as we have selected Lambda pattern, now it creates the event pattern for us. I'll show this event pattern is very important, so I'll show you in detail. But what you can do is you can customize. Let's say you can give it a name. Hello, right? So I'll show you what we can do with this. So what we are trying to do is we are trying to create a rule, and whoever consuming that particular event, so let's say I'll fire a event, and whenever I'll fire a event, my on the at the firing time, I'll provide the source AWS Lambda. So any service, any application will be listening to that particular rule, saying that I'll listen to all the events which has a source AWS.lambda. It's just a string, you can name it anything. So any service saying that I'm listening to a rule, and if that particular event has a source AWS Lambda, then I'll listen to that particular event. So that's the rule we are creating. So we said because we want to do the Lambda, and the default AWS bus, because generally it's works with the default AWS bus. You do not have to create your custom bus. Target means if that particular rule matches, event occurs, and if that particular rule matches, so which function or a service should be gets called. So you can specify, let's say you have multiple few services. Not all AWS service can listen to a event. So API gateway, batch job, CloudWatch, code pipeline. We have discussed code pipeline in our last class. EC2 instances, Kinesis stream, and Lambda function. So at this moment, because it will be easy to explain and it will be easy for you to understand with the Lambda function. So I'll select Lambda function. That means if someone produce an event, if that event matches this aws.lambda source, so that event will be received by that particular Lambda function. Now we have to specify a Lambda function over here. So in this case, at this moment, because I have already a Lambda function in my list, so whatever Lambda function, let's say we have a 10-20 Lambda function list over here. So we can select that these Lambda function from this. So at this moment, I have only one Lambda function, demo handler something. So that's why this function is listed. If I had 4, 5, or 10 Lambda functions over here, the list will be longer. So I can select that Lambda function. I'll show you what this Lambda function has, but at this moment we do not have to configure aliases. We do not want to change any alias. We do not want to any input. Matched event means whatever the event occurs, whatever we mention in the source should be matched exactly. So we are saying matched event. Retry policy, we are saying that if event gets fail or the service does not receive, so how many hours this service this event should remain in the service bus. So its default is 24 hour, and you can uh, change that information. You can change to 1 hour or 2 hour. So if event is not being processed by a receiver, event will stay up till, by default it's 24 hours, so I'll not change it. Retry time, how many times it should retry. By default it's 185 times, so you do not have to worry about it. And dead letter queue, that means if unprocessed event, what you want to do if event does not processed by any service. So what you want to do at this moment, we are saying we do not want to do anything. Otherwise, what we can do is we can say that send it to a queue or send it to a particular service, so that we can understand what happened with the particular event and why that event was not consumed by anyone. So this is it. I'll create this. Let me show one more time. Name, description. We are creating a pattern. I'll change this pattern. I'll show you what we can do, because that's the important part. This pattern is mainly the part which identifies how you fire an event and how you consume an event. And then we select the Lambda and everything. Event bus will be the default, and we are saying when the target, the one which will be receiving that function, that event. So we are saying Lambda function. This Lambda function will receive that event. Create. Okay, so now we have this demo second rule. This rule says event pattern. So if it will have a source which contains AWS Lambda, then it will fired, and this Lambda function will receive that event. So let me show you that Lambda function. It has nothing but just a simple code. We have seen Lambda function quite many times, so I guess you will not face any problem to understand. It's just an export handler. It's already deployed, so you can see it's I'm consoling the request, whatever the data it is, we'll console it and then return body, just a new hello cdk uf at event.path. There is nothing else in this function. Okay, so now when you create a rule, so when what we are trying to do is we are trying to implement event-based service. So someone will create an event or a fire an event, and someone will receive based on that event. Someone will execute some service will execute something. So we have created a rule that if event is has such qualities, then this lambda function should be executed. So we have implemented the consumer. The producer, I'll have to show you code, but AWS service has given us a feature where we can test our services and we can test our events. So what I'm going to do is on event bus, we have a button send event, or we can see it directly from the rules as well. So we have event bus function button two or three places. So let me click send event. Now the event bus, we have a default event bus, so it will remain the event source. Now that's the source which we have created a moment ago. And we said the where it is, yes, we said AWS Lambda. So whenever we will fire an event, source should be same. So I have to say AWS.Lambda. It can be anything. Detail type. Now let's say, as Avaris has mentioned, we have an order service, we have an invoice service, we have uh, payment collection service. So we can name our services by type, and if we are filing in a particular event, so let's say we can say order service, order event, invoice service. So we can name anything. So let's say invoice service or invoice event, whatever name you want to give it. And that's the JSON object event details. So four properties are important while producing an event and consuming an event. These four properties must match, or one of them must match to exactly produce and consume an event. So so at this moment, I'm just saying customer name, value will be Varis. So that's our JSON object. So the event type, detail type, event detail, source, and bus. These four things needs to be mentioned. We are not going for the additional option at this moment. Once we fill all these properties, what we can do, we can click the send button. That means we are firing an event. Send. Not authorized. Why I'm not authorized? Not authorized for the source. Just fire the event. I had to change the name of source, but now our function will not receive that event. What we can do is we can see, check out the logs if our function received that event or not. Okay, so uh, as expected, it should not receive any event, but why it is not allowing me to generate an event? Let me edit the rules instead of maybe the name of this rule is causing some problem. So what I can do is edit. Name it hello. Okay, so I have created event pattern. The source is hello. Now what I'll do is I'll generate event with the hello. And I send the customer name Varis. I'll fire that event again. Okay, so we have logs now. So our function gets called because of that particular event, and it receives the information, as you can see, source hello, time, version, detail, invoice event, and the customer name Varis. So what happened is we have created a rule which is an important in every case. So all the services or the application which want to listen to a particular event, they need to be a part of a rule. So important thing is we'll be creating a rule, and that rule has a pattern that if a event fired has this particular type of pattern, then these are the target. At this moment it is one. Multiple targets can be registered, so you can register a 5 or 6 services for a particular, as Varis showed us that user select the order, so user click the checkout button, so you will fire an event to checkout, and for that checkout service it will be an event, and 3 or 4 services will be receiving that particular services, that particular event. So in our case it will be a target, so there will be a invoice service, it will be a payment process service, it will be maybe updating the product service. So there will be three lambda functions, so we can register 3 lambda functions as a target over here, and this will be the pattern. So whenever we'll be producing an event, it will be an hello, and that's how it will be get called. And we saw this by generating an event ourselves. Let me show it again. So what we can do is hello. Let's say I'll change name order event. What you can do is in pattern you can customize what type of information you want it to hold. you can see it's an order event. Send an event. Okay, so we have received the event and you can see order event. Now, another important part is when you are creating an event pattern, you can specify source, detail type, and detail. And you can create rule that either you want to listen to an event based on source, based on event type, and based on detail. I'll show you these properties while we are coding, but these four properties are important, and that's how you will listen to an event. And if you understand this, how it's works with the code, it will be quite easy. So let's come back to our example. So we'll be using the step number 15 event bridge, and it has a first step event bridge with lambda. So what we are trying to do is we have a two function, consumer and producer. So we are trying to do is we are trying to produce an event from a lambda function, and we are consuming an event in another lambda function. Then we need to, if you can see easily that we are creating a lambda function in our stack. It's a simple, and we are giving a put access to put events to this lambda function. So what we are saying that this lambda function can produce an event or can generate an event or can register an event inside the event bus. You can name it anything. And we have a consumer function. You can create an API gateway, so you can send a request through URL. I'll do it directly, so we do not have to worry about the consumer name. And now again, you can see rule. So the point which I showed you, the event rule, which is an important. So we are naming a rule. We are providing the targets that that particular lambda function should be called when this particular event occur. It's in a description and event pattern. So event pattern is most important. Either you can provide a pattern based on detail, type, source, or event bus. So as you can see, this event pattern says if event which has been generated has a detailed property, inside it it has a country property, and that country property has a value pk, then this lambda function should be called. And that means that event will be consumed by lambda function only if this pattern is matched. This is the main part. If you understand this, you will understand how these events will be talking to each other. So let's us move to it. So what I'll do is okay. So we have a consumer, we have a producer. So what I'll do is because we do not have to worry about how lambda function is being created, so I'll use code directly. Consumer will not be doing anything. I don't need these at this moment. What I'll do is so whenever event occurs, this function will get called, and there is an error. Okay. this function will be called, and it will return, it will just print something and nothing else. So we'll just consuming this event. I just did it mistakenly into the producer. It should be inside the consumer. For producer, what we need to do is now again, this handler is very simple. What it's trying to do is AWS.EventBridge. You can specify the region if you want to use the region different from your default region. Otherwise, it will be your default region. So you either mention or do not mention. It's not a problem. You are creating an EventBridge object, and then you are trying to put event. So you are just putting an event inside the event bus. So you call put event, and then you provide entry. So this is actually you are producing an event. So the way I showed you here as a testing tool, event bus, event source, detail type, and detail. This is exactly the same. What we need to do is we need to provide event bus, which will be default, source name, whatever the source should be, and the detail type, and then detail. That's the important part. Otherwise, everything else will be remains the same. So what I'll do is first take this from here. I need to import um, from AWS SDK. EventBridge. And then what we need is we need to create instance of EventBridge. And at this moment, I'm removing so that you can understand that if you have a default region, then you do not have to worry about. And then you call EventBridge dot put events. Inside that, you need to specify entries. I'm just typing because you need to understand this particular portion. Other things are we have seen quite many times. Entries, it accepts array, and each element is an object. That's how you create it, and then it produces a promise. So what you need to do is await, and after the round bracket, you need to call promise. That's the important part. Await EventBridge.put event, and then provide the object. In that object, we have a property entry which accepts the array, and each element is an object. And what we need to specify? Event bus name, detail, source. These four are the important part of. So what we are trying to do is we are creating a function. Let's say it's an order service. It will generate an event. Okay. For this bus name, we'll provide default source name. Whatever source name we'll give, inside the rule we have to specify that says exactly same source name. So at this moment, let's say I'll say order service, and the detail type, add order or update order, anything. And this detail is in a JSON. It's in a string. So you if you have an object, so what you have to do is you have to stringify that particular object. So what I'll do is send order stringify. So either I'll create object over here, and pass this A over here, or I can just create object on the fly just to explain you that that's not something difficult or anything else. Okay, so let me say product name. Let's say t-shirt and product price. I can just name it price. That's how you. Let's say I'm saying it 56. At this moment, I'm hard coding it from producer end. So we'll always produce an event with the name, t-shirt, and value price. I'll show you how we can customize it. We'll receive this from other sources. So that's our particular event, and we have this result object. What we can do is we can um, show it in a console, as well as we'll show it here. That's our producer. So whenever this function gets called, it will put an event inside the event bus. Now, whoever listening to that particular event, whoever polling to for that particular event will get called. So this function will produce an event and will consume an event with this consumer. Oh my! I again did. Okay. So this function should be here just because of the name. Otherwise, it's not a problem. The consumer function should accept the event and just print it on the console. We can do anything, but at this moment to learn. And the producer function will create an event, put it event in the event bus. The important element is event bus source type detail, and it will just show to the client that what I can see is. Okay, so now we have created the function to consume and produce the event, and now we need to write an infrastructure code so that
Zeeshan,
we
I
can.
just have,
Yes,
why in your consumer you are returning something?
yes. And we do not have to return something. I just I'll have to show some things. That's why we do not have to return anything. It's uh, uh, what I can do is I'll remove this, so it will just log on the console. So we do not have to worry about this.
Thank you.
So that's our
Because
producer, and
my
now
question was,
yes,
just so that everybody understand, my question was because it is they are being called asynchronously. There is nobody
yes,
there to listen to the return message.
yes. Basically, as we are talking about
Zeeshan, I cannot hear you. I can't hear you. Your voice is lost. Your video is coming, but the audio is not coming.
You are muted.
can you hear me now?
Yeah.
Can you hear me?
No, yes.
Okay. Okay. So yes, the point is valid by raised by Zeeshan Khan that basically whenever you are talking about a function or a service consuming in an event, that service will not be returning to, because there's no one listening to that particular event or function. At this moment, I'm just creating a dummy function and I just pick the code. That's why it has a return. Otherwise, you will be not returning function. You will be keep updating a database. You will be calling any other service. You will be updating logs, or you will be writing to somewhere, but you will not be returning to the caller. So that's why you do not have to worry about it. At this moment, it is there just to write a code. It's nothing else. Okay, now from the stack perspective, it's quite simple. You need to create a lambda construct for consumer, lambda construct for producer, and you need to create a rule and to grant event access. So for that, let's go back to. So what I'll do is, at this moment, I'll keep the functionality as it is. So that's our, I need to import lambda from AWS lambda. You need to import events and event targets. I'll explain what's the difference between the both of them. Event targets are the targets which we will create, and so here we have a lambda function. We do not need this. It works directly, so we should not worry about this. Okay, now we have a function lambda producer, and it has a handler function. So producer dot handler. So it's a producer dot handler, and then runtime is runtime directly. We'll do same for consumer. We'll just change the name. And we will have, so we have a two function, a producer function and a consumer function. Now the producer lambda function wants to write in EventBridge, and we have learned while learning IMA policies and services and policy statement that if one service want to talk to other service, we need to give access particular service to other service. So in our case, here we are giving access to events.eventbus.grant put event. So we are giving the access to lambda function, producer lambda function, that you can put something in. So we have imported event.eventbus.grant put event, and we will give it a name. So it should be same. Now this lambda function can register or a put or a fire an event that will be registered to the event bus, and then consumer will consume it. Another important part is rule. So for rule, let me just pick the first line so that I can explain you. Forget. New rule. Okay, so rule, the construct. So we need to provide this event rule, and then we need to provide properties. So this is exactly same pattern we have been creating construct multiple times. Now we have a properties. that we need to provide the either name, then targets, and the pattern, event pattern. First of all, let me provide the targets. Target means which function or which service gets called when this event is occurred, or who is listening to that particular event. Okay, now in this case, the event targets service or library will have the properties. So what we need to do is we need to call new event targets dot. Now we have targets which service can listen to an event. So AWS API, batch, CloudWatch, build projects. So whenever some particular event occurs, you want to start the build process of your application. You need to execute your pipeline. You need to fire. You need to register something into queue or send an SMS or email, or you want to call a particular function. And then inside that you will provide your name of your consumer function. Now what I can do is I can provide another, and I can provide another function. That means if that particular event occurs, two of the lambda function will listen to it. So you can, it's an array. So you can provide as many targets as you want. Okay. Then event pattern. This event pattern also accepts account. Account means if you want to listen between two different AWS accounts, for that you have to create a different bus service. We are not going over there at this moment. So we have four properties. Source, just showing you, will not be using every property. Detail, detail type, that's it for now. So what we can do is when we can register event either based on source or based on particular value inside the detail or the name of a detail, or we can do it multiple. So let's say, for just to verify, I'm just creating a source, then I'll add another. Inside that source, I'm saying is order service. This source should match over here. So whenever a particular event is registered in event bus and that event has a source value of order service, then this lambda function should get called. Or I can provide multiple source. Let's say order service and maybe payment service, just to show you. So if a particular event occurs with the source order service, this lambda will get called. If a particular another event occurred with the source payment service, even then this lambda function will be gets called, because we are saying this lambda function should be called in case of any of these sources. For us, we do not have these sources, so I'll just add source and we are done. So I'll show you detail as a next example. I'll just let me let's first complete this, and then I'll customize this event. Okay, so I guess we are done with this. We have a consumer, we have a producer, and we have this stack. Let's try to run this code. cd deploy. Now this deployment will register two functions, two lambda functions, and it will create a rule in event bus, and that rule will be this one. So at this moment, I have rules. First, our rule name, first rule, our rule name, second rule, and there will be another rule. As I have not given rule name as a custom, what you can do is you can specify rule name. So it will be a specific name and that name will display here. At this moment, I have not provided it. So AWS will generate a particular name, whatever AWS thinks. How can we get first? Is it really deployed? No. Okay, I'm on wrong screen. That's why I was worried why it's so fast and deployed so fast. Okay, CDK deploy. At this moment, we have created two Lambda function in the same code base, but the main objective of event bus is it's a decoupling. So these two Lambda functions are not directly interdependent to each other, or you can create two different repositories or two different services which will be handling by two different developers, but they'll be talking to event bus using the the event they produce or consume. Meanwhile, it's deploying as it takes. Sometimes it takes time. So I'm just showing you, but I'll explain it again. What we can do is, at this moment, we are saying that an event which has a source value order service should be consumed by this Lambda function. We can specify detail over here, detail type, detail. And let me show you what we are generating. We are producing an detail which has an object and it has a property product name as t-shirt and price as 56. So what I can do is I can say that if it has a price property, I'm providing array over here because we can provide range of values even in case of target, even in case of source. So we can provide range of sources that this source can be consumed by this Lambda function. Again, we are saying if this detail price property has either value of 50 or value of 21 or a value of 70, then this Lambda function should be executed. So we can customize this. Let me see. Yes, it's done. So at this moment, this particular property is not deployed. So let's see what we have here. we have Lambda function producer and consumer. So let's open both of them. And in the event bus, we have rule name demo event stack. Because I have not provided custom name, so AWS has generated the name, and it is a pattern saying source order service. So whichever event has a source of order service, it will work for it for that. Now with the producer function and consumer function. So producer function can be called by API or an AppSync function or whatever way you want to call a Lambda function. At this moment, to test our service, what I'll do is I'll just create an event from here so that we can call that Lambda function. So that's our Lambda function, which will register event inside event bus. I'll create an event. And create. Okay, I'll call test. So it will call the Lambda function and it will produce an event. So before that, let me just go over there. That's our consumer function, and it shows it has an event bridge connected as well. This is a simple function, and we'll have to see the monitoring part of it, the logs. Just to see that event occurred and it's consumed by that Lambda function or not. At this moment, there will be no log because we have not executed that function yet. Now from producer function, I'll call this test. It will execute this function body and register an event inside that event, and which has a source of order service. Okay, so it generally gives us object. As you can see, I have printed the object of result. So what it's saying, failed entry 0, that means there is no failure. So it registered the event, and entries which event is registered, so it has an event ID. So that means events gets registered. Now we need to see in our consumer function. In consumer function, we can at this moment only see the logs, that if that function gets called because of the event firing, so we'll have something inside the logs. Okay, we have logs. That's what I have output. I have printed on the console. So you can see ID, detail type, add order, order service, and values t-shirt and 56. That's what consumed by that Lambda function. Our producer function generated an event, and we have consumed it. Now, if I'll call this test again, it's success, and what we can do is refresh the log. So we'll have another entry, but because our function is hard coded, so we'll have same value. So what at this moment we have to customize the code and then have to produce the event again. So to test it, I'll follow the same pattern which I showed you guys, that what we can do is in the event bus we have a send event to test our event, and here we need to provide a specific source which is order service. And now good part is we can provide any detail type, order 123. Why? Because in the rule we have not mentioned anything about the detail. In the rule we have mentioned only about the source, so we can do anything here. Why it's not allowing to edit? At this moment I'll provide the same value. Well, so I have selected the default bus. Source name should remains the same, otherwise all the details can be changed because rule only depends on source. Okay, so click on this invalid syntax. Okay, gets registered, go to the logs. And see, order service, add order 1234. So detail type can be any. Product name shoe, price 12. So we can produce as much, if we can fire as much as event. This consumer function will listen to that events, these events. Only if you change the source, then it will not get called, because then it's a completely different rule. So it does not match the rules. That's why your lambda function will not get called. That's how you can customize it. Now the last thing is what we did is detail. So what we're trying to say is, if someone produce an event with the source order service and it has a detail property which has a price property, and that price property can be 50, 21 or 70, any of these values, then that lambda function should get called, otherwise it should not get called. So let me deploy it again. In our producer we are saying 56, so I mentioned 50, 21 and 70, so let's make it 21, because it's at this moment it's hard coded. You will be using any API post or get body, and you can manage this. We are just testing, so that not to worry about it. On the face of it, it seems like it's just on a creating in a rule and then two function gets called, but this is a major architecture change of the event system. And if you understand the basic information is the enough to produce a very large application, to create a very large application which can work on the communicate based on events, and the services will be communicating based on event. They will be loosely coupled and it will be quite well scalable. Okay. Meanwhile, it's deploying. Let me just review the code, explain the code again, so that we can utilize the time. What we wanted to do is we wanted to create, we want to use the event bridge so that our application or services within an application should be decoupled. So order service, payment service, and any other service, update the database, you want to update the database, all the services should be decoupled with each other. So if there's a failure in one service, it should not affect the other service. If there is a problem in one service, other service should not get affected. And if you change the one service, it should not affect the other service, because they are not directly integrated or directly coupled. They are different services and talk to each other using the events. So that's why you can use the event bridge services and event buses. For that, what we need to do is we should have an event bus, and we have event rule, so that whatever service uh, produce particular rule, produce an event which specify, or which uh, what you say, I'm not able to what we can say, mm, which will be completely based on particular rule. If the rule has the same value, and you producing an event which allows that particular value, then that target function should be called, a target function or service should gets called. So that's how you use the event service. At this moment, demo event is deployed. Now what we can do is, let's go to the function, producer function, and okay, so we have a new function deployed. The production producer is doing the same thing. It's generating an event with the event bus name is default, source is order service, detail type add order, and detail is in particular. Object name is t-shirt, and value price is 21. The consumer function is the same. What we need to do is, let's produce an event. I'll call this test function. It generates and failed entry 0. That means entry is working. Event ID, we have this event ID. Let's go to the consumer log. Okay, we have log, and we can see value is t-shirt and 21. Now again, to verify that the way I'm saying it works this way, I'll go to the event. I'll name it order service. You can give it any name. Product name shoe, price 70. Generate an event. Let's see if we have. Okay, we have this event and we can see price is 70. Now, if I'll change the value to 30, so 30 is not a part of a price list which we have provided. Send an event. As you can see, we do not have any update related to that function because we do not have the information we have provided. Our consumer function is what is consuming an event based on a particular pattern, event pattern, which must have event source named order service, and price should be 50 or 21 or 70, otherwise it will not get killed. So you can customize your events in quite detailed level that you want to fire or consume a particular event. If that particular event has these values, it has a particular source and type and object properties, then you can consume that event or not. So that's it. AWS has given us quite extensive detail, and you can use based on these functionalities. This event pattern is the main part. If you understand this, how you can customize it, then everything will be easy to implement. I guess this is the main part of it to use and consume. Otherwise, there are quite many details which you can easily can explore and go over these details.
Thank you so much, Zeeshan. It was a marvelous learning experience. If anybody else has to say anything, they can add anything. Paris, would you like to add anything?
Yeah, I just want to say one thing that I've been asked like thousands of times that how did you implement that webhook in project 14C and 13C? So I used EventBridge. So I made a pipeline that was building my front end code, and then I connected that pipeline with the EventBridge, and then I was sending events from my client side using an AppSync API. So whenever that AppSync API would send an event to the EventBridge, that would trigger my front end pipeline. So yeah, that's how I implemented it. So yeah, please guys, please stop sending me messages now. Yeah.
So, Waris, if I understood it correctly, from the front end, whenever you add something to your database, you fire an event, and that particular event just calls your code pipeline, and then your code pipeline starts to start building again.
Yep,
That's it.
Yep.
Okay.
Thank you so much, everybody. Thank you. See you in the next class.
Okay.
Bye.
Okay.
Bye-bye.
Bye, everyone.